Okay, hi. This talk is about how we migrated from Maven to Gradle. We had a big project and just wanted to try out Gradle because it was hip, and we didn't really need to go to Gradle, but I show you how our experience was. And that's the first part. The second part is after feeling good with Gradle, we used it in a new project, including Docker to implement a pipeline based on Gradle. And yes, I will demonstrate some code and some details how we implemented it. Okay, something about me. I'm a software developer with some fun using tools like Docker and Gradle to make DevOps and other things besides developing. I'm employed at a German firm named Hypoport. You don't know it probably. It's not Twitter or Google, but it makes fun to work there. I'm on Twitter and I have a blog. Yes. So, two parts. The first one, our experiences about migrating from Maven to Gradle. The second part, implementing a pipeline with Gradle and Docker. We started with a multi-project Maven project, about 300 project files. It uses GWT frontend. We have an AngularJS frontend. There's a mixed usage of TestNG and JUnit tests. We already implemented a little Maven plugin, which does something like Gradle also does, to only build changed modules. This is called incremental build. And there are some Maven-specific hacks which weren't supported by Gradle out of the box. And I show you some code how we tackle them. Okay, the most important plugins we used, starting with the build init plugin. That's a Gradle plugin that comes with Gradle. You can give it a path to the Maven root pom file, and it generates build Gradle files from them, including dependencies and what you need. It doesn't migrate your plugin configuration or other specific Maven details. For example, the possibility in Maven to use provided scope in jar files isn't supported in Gradle out of the box. So Gradle generates some comments and adds the provided scoped dependencies as compile dependencies. So you have to manually resolve it. Another plugin, the GWT Gradle plugin, helped us a lot to replace the usual Maven plugin. It's I mentioned it because it's quite convenient and it just works. It's great. So the second point here, Maven scope, propagation, and dependency fun. That was not too much fun. Because Maven sometimes allows you to use dependencies which are not really on your current sub-project, but also from your dependencies. So through transitivity, you can reach dependencies which are not declared in your pom file. And Gradle, most of the time, doesn't work with such a setup. Then some plugin which is missing, you need patience. It's especially because of the dependency problems. You compile your project, Gradle tells you that the dependency is missing, and you have to add it manually. Then you compile again, and well, that's no fun. It looks like that. That's an extract from our log where we, added the dependencies step by step until we finally made it to compile our project. Without test compile, without running the test, only compile the sources. That's about 1 month. We started at something like a FedEx Day. You know it probably from Atlassian. They have a day where the developers can do what they want for a day. And after that day, they have to present their result. And we tried to migrate our Maven project to Gradle. And yes, what we managed to do in 1 day was to make it compile. So this is to show you, the colors are great, to show you the problem with transitive dependencies. You see project A depends on project B. Project B depends on project C. And in Maven, you are allowed to use in project A classes from project C. That's okay in Maven. In Gradle, most of the time it is not, so it won't compile. The solution is declare your dependencies in project A, there where you need them.
So you have across the project B and C are in project A, they have to declare.
Yes. Now some code. How can you make such a transition more easily? You can globally declare some dependency versions. That's shown here. That makes it easier to override transitive dependencies. We declared it like that, and then we tell Gradle to use those declared dependency versions. That means if you have log4j in versions 1.2.16 and 17 in different sub-projects, you can override it and use the most current one. That was quite convenient during the migration phase. And I guess it's still convenient during your normal development. Yeah.
I see you have all there. Did that I assume that doesn't cause any problems with plugins and their configurations that they might define? Because sometimes we find that when people get aggressive and do an all, it doesn't just affect the projects, it affects plugins that have their own configurations. Yeah. And you suddenly pulled something out from under it.
Okay. The question was if how we use it. The question was
more scoped down from all instead of all just on specific configurations.
Your question is that those enforcement also overrides plugin dependencies. I have no bad experience with that, so I guess it's okay, because the plugins mostly only are used during compile and build time, and these dependencies are also during compile time, but also during packaging, for packaging your web apps. So from my point, it works. Yeah.
There's something to be aware of.
Should be
What?
Should
Yeah.
be running the build the Gradle class path versus the project path. Should be good.
Sure, sometimes it.
Yes. So some of you might know from Maven, there's an enforcer plugin. This line is one aspect from that plugin. You can make sure that you are always using the same dependency version of one dependency. This helps finding dependency problems during in your subproject. This is how to globally exclude dependency by module name in this case. So you are not enforced to exclude it on each dependency which transitively depends on it. You can make it globally. It's quite convenient. And another convenient example for globally use dependency based on the group name, you can say, I want to use the Spring framework in that version. So if you declare your dependencies, you don't have to use or declare the version, because here you can just override it or set it. It's a bit dangerous because when building, for example, a web app, it doesn't use these dependency enforcement. It uses the declared dependency version you have in your subproject. So you still have to make sure that these versions are always in sync. How can you do that? You can globally declare such a list of dependencies. This is only to declare them. They are not directly used in your project. And you can also combine several dependencies or make some specific configuration on a dependency. And then when you want to use it, you just have to reference the global available libraries variable. That makes it very convenient if you want to share your dependencies from one root project to to your child project. So you only have to change in the root project your version numbers, and everything is okay for your child. The one thing Gradle does not solve is using a provided scope in jar modules. It only works for Word or web apps modules, and the guys at Spring created a little project which helps you to use provided scope even in jar modules. It's quite simple, and if you want, I can show you some example later. It's only apply your Quant plugin, and after that you can use these provided scope to declare your dependencies. As already mentioned, the GWT plugin is quite easy to use. We even removed some configuration because the defaults are good enough. Yes, just great. Another example which was important for us, we only wanted to use the Groovy compiler and disable the Java compiler. And this is how we managed it. We emptied the Java source DIRs, which are read by the Java compiler, and added them to the Groovy source DIRs. So the Groovy compiler picked up the Groovy as well the Java source files. Then about the mixed use of JUnit or Spock and TestNG test frameworks. Gradle allows you to say I want to use testng. It's simply this line. But it's mostly a switch between JUnit or testng. To use both, you have to create a known task of type test, enable testng, and make the check task depend on testng. So you more or less check depends on both testng, implementing testng tests, and test, implementing JUnit tests. So check collects both. To make your reports combined, here's another example. You declare such a task of type test report, tell it where you want your reports to be saved, and make a report on the default test task and your own testng task. Then you still have to tell this task to run after testng, and check also lets the aggregate test reports run before check is finished. Below, just an example how you can pass system properties to your tests. The line above task with type test applies the system property to JUnit as well testng test. Coming from Maven, we are used to declare versions on your POM files. You don't really need versions until you publish them. So publishing in Gradle is made through the publish plugin, and you can declare your version as late as possible. It's like that. Just an example, using the current date as a version number. We also append the git hash, but this one just works, and you don't have to pass your version number through all your projects. It's only here at your publication. Yeah, as you have seen at the git log, it's quite time-consuming to migrate a bigger project to Gradle. The current state, we don't completely use Gradle currently at that project, just because it's not finished in all plugins and configuration steps. So yes, it's only an experiment. But some experience about Maven to Gradle comparison. Gradle has it feels like a long evaluation phase, but complete build time is a bit faster or in par with Maven. So there's no lost on time, only it feels a bit long when the evaluation phase is running. The feature from Gradle to build incremental is not so easy if you have a CI server with several agents. The agents cannot share the Gradle cache or the Gradle daemon, but this is what Hans already mentioned for future versions, and I guess that will be quite fun. The IDE support, we use IntelliJ, but it feels a bit unstable and not as good as Maven. Yeah. The question was how we use the Gradle build files, whether we import them in IntelliJ or if we use the IDEA plugin. And we use the import feature from IntelliJ because we don't want to get the knowledge for the IDEA plugin modifying XML. It's no fun. Yeah. In our team or in other teams, the most important question is why Gradle? What's that all about? And Maven works enough for us. I will come to that back later. But after that FedEx day, after our presentation, Gradle has become the tool for new projects we are implementing in our firm. Compile our classes, and that was for 2 people, but on 1 PC. So you see something quite fast. It feels good because the compile phase just worked after 1 day. But then there came the test compile, and you want to run your tests and you want to configure your plugins, the GWT. That was about several weeks or months because we had to learn about Gradle, how it works, the concepts, and to find plugins. That was time consuming, and also for 2 people. Yeah. The question was about the dependency inheritance. I have to explain a bit more. ABC weren't in a multi-project build, but separate dependencies. Like our project was Project A, then B is Spring Framework, and C is Commons Collections, for example. So it's no multi-project build. In multi-project, sure, you write project : project name, and then transitive dependencies are resolved perfectly. Again, the question is about the version during publishing. I don't really get your question. I try to explain a bit more about that. The version isn't used in Gradle for the build time, but for deployment to an Artifactory or Nexus, you need Maven coordinates. And that's why we only need it for the publishing. So did that answer your question?
In Maven, the version is mandatory, so you have to define the version tag. So when you migrated your project over, did you define the version in the file, or you remove the tag because it's not a mandatory?
Okay. The question is, due to the conversions from Maven to Gradle, if you kept the version tag. We moved it. Yeah. The init plugin, I guess it's copied it over, but we didn't want to change our source files for each version update, so we removed it.
Do we have time?
Yeah.
Did you have Maven profiles, and if you had to convert them into Gradle, was it
Question is whether we had Maven profiles. We didn't have any that were applicable or that we really used.
do you deploy to any container, and what was the container?
That we didn't solve yet. That's the part we are still working on this big project. But I come to that back later in the next part.
Do you use Maven release plugin?
No. No. Question was if we use the Maven release plugin. No, we didn't use it. Okay. After our experiences with Gradle, we decided to use it for a new project and use it for completely everything, even coordinating our deployment. I hope you can see enough. Is it okay? Yeah. First thing, we use TeamCity as our CI server. TeamCity has a feature to pass some build artifacts through your build types. And we pass, for example, our version number for the published artifact. We start by using Gradle, call build and publish. This one generates our version, and this version is passed through the whole build chain. Our artifact is deployed in Nexus, and we use it in the next 2 steps to deploy our web app. For end-to-end tests, these are integrative tests on our front end. End-to-end testing is a word coming from the AngularJS theme, where you mostly have JavaScript tests, but at least a minimal backend, but not your complete backend. Contract testing is about how we make sure that our application works together with another product in our house. When we are deploying a new version of our artifact, we want to check against the other product if we can communicate as expected. And contract testing says we define some tests, and if these tests are green, we have defined the contract which works. Next step after these integrative tests, we make Gradle use the Docker API by building a Docker image. That Docker image is pushed to a private Docker registry. After that, we, again, with Gradle, we make it talk to our QA and production server. There is a running Docker API listening on HTTP, and make it pull from our Docker registry the new image. And we update our application by stopping the old one and running the new one. Some details. Build and publish. It's Gradle. End-to-end testing and contract testing. I'll explain a bit more. We use the Quant Plugin to delegate to our JavaScript build tool that's named Quant, and that plugin allows us to generate our JavaScript and move it or copy it to the Gradle build directory. It also supports inputs and outputs, which allow Gradle to recognize if it has to do something or not. So it's quite performant. Sometimes the Quant plugin is a bit unstable. It feels a bit surprising when it asks for an npm or node installation, but we haven't found the reason yet. The end-to-end tests. Protractor is an implementation on top of Selenium. It allows us to write end-to-end tests in JavaScript. And we have a little setup with a reverse proxy to make our setup a bit more convenient to combine several web apps on one port. We have two backends, two running web apps, one a backend, and the front end contains our JavaScript. And the Protractor tests are executed by calling a shell script. So Gradle helps us by not standing in the way. With Maven, you had to find a better plugin or use Gmaven or something. Gradle is more or less groovy, which makes you execute some shell commands just inline. About the contract tests, we don't want to declare an API or a schema, because you even have to version that one, or that would be a shared dependency, and dependencies are not so convenient. We try to define our correct behavior by defining some tests, and when they are green, everything's okay for us. During our Maven contract test phase, we start the other web app by using the Gradle cargo plugin, and then we perform our Java tests against, or by issuing HTTP calls to that backend and wait for the test to come back. Yes, I can show you some detail how we the reason why it's a bit more complicated, if we change our web app, we have to test against the remote web app, but also when the remote web app changes, it has to make sure that our current version also works with them. So it's not by implementing a test in our project, but also the other web app has to find our tests. So during the build pipeline, we know about our version, or we can ask our production server for the current version, and depending on which version we have to select our matching tests. This is by lazily resolving a dependency. We get the version from our build pipeline and make Gradle resolve it after the evaluation phase. This is because the version has to be evaluated before. It has to be found in the project environment, or it has to be in a text file. And well, we have an own project, not in our multi-module project, but beside it, named contract tests. And yes, it's lazily resolved, so we can run it. Yeah, I can show it in a better context later. Now, after the end-to-end test and contract test, we are quite sure that our application would work on production. So how do we make a deployment? We use Docker by packaging our web apps in a Docker image. Docker is container technology based on Linux containers. It's no VM like VirtualBox or VMware. The images contain everything, including the OS, so we can choose as developer not to use the one which our operations decides, but we can choose for ourselves. We include the JDK or Java runtime and our application and everything we need. It's more or less portable. It only needs some Linux kernel. And for other platforms like Windows or Mac, there's an VM solution named boot to Docker. The best thing about Docker is that you don't need SSH. Docker has a remote API working on HTTP. So you as developer don't need to log in on a shell. You only talk with Docker. Yes, and once defined or once created, a Docker image can run locally on a developer machine, on a QA machine, on production servers, everywhere. Yeah?
What's the application server that you were using to deploy your web app? Was it Jetty or Tomcat?
The question was which application server we are using. We're using Spring Boot, and inside it we use Tomcat.
And may I ask what's the JVM heap size that you were using?
I have to look up. The question was which heap size we're using. I'm not sure.
Because I've tried Docker with like say 512 meg.
The question is if you can simulate a production near environment with Docker. The concept of Docker is that you are based on a kernel and on the underlying operating system, but you can more or less make a context switch to your container. So you are dependent on the kernel and on the underlying host, but the memory and other aspects can be modified by C groups and other Linux concepts. So if you can apply them to your local machine, then you can simulate the production environment. But we didn't do it because we didn't have any problems yet.
Or OS files with the host OS?
The question is if we share some host files or host libraries when we are creating a Docker image. Docker images work a bit like VirtualBox or these VMs. That means you have a base image. For example, you say in your Docker that you want to base on Ubuntu. And this one is copied from the remote registry and copied to your local disk. So there's nothing which is shared. But I'll show you later, based on that image, you can stack some tiny layers on top for different images, and they all share this Ubuntu image. Just an example, more or less a minimal example from our build files. In Gradle, we are using Groovy to talk to a local Docker installation. What we do is we are pulling a base image from our local private Docker registry. We are building a current version of our application image, tag it with a current version, push it to the registry, and clean up a bit. So a bit more detailed, we have a Docker registry running so that we don't need to use the public Docker registry. Then, well, that's all, more or less. The result is that we can access these Docker images from every CI server, from our local machines, and from our production servers. It's just like Nexus. Now come back to your question. You see here the Debian base image. We can add some custom files, or we can execute some commands. And each command or file which we declare in our Docker files will be added as a tiny layer on top of these base images. these images then can be started. A running image is called container. And well, you can run several copies of an image and have several containers. When we have several versions of our application, we don't have to copy these base images. We can reference them, so we don't have to copy a complete OS. We only have to stack some layers. We use that concept by defining an application base image which contains our JDK in a desired version, and we only add our application jar. That's all we do. Now, after we have created our image, we have to deploy it on our QA machines or on production servers. Here you see docker-h. That tells Docker to talk to the remote server. So, as I mentioned, we don't need to SSH into the remote machine. We can talk with Docker. On that machine, we tell Docker to pull our created image. It pulls it from the private registry. Then we can stop the running instance, the old version. We remove it, and we run the new version of our application image. This PS is only for little logging to see which containers are running. It shows a list of running containers with open ports and some details. When the time permits, we can go into detail. That's much detail. More or less, you will see here Docker supports exposing internal Docker files or internal files from your container to the outside host. So we can expose our logs or get our logs even after a container has been finished or removed. As mentioned, we use the cargo plugin to run other web apps we are talking to. And well, to make this a bit more beautiful, you can also use the quite new Gradle Docker plugin. It helps you building a Docker image and also, I guess, deploying it or pulling and pushing it to a remote server. It was too new for us. We started by using the remote API. Okay, questions? Yes. No, we have currently 3 projects for, question for the camera. If we have several projects for the Docker deployment and our application and such, we have 3 projects. One multi-project project with our application and the implementation of all tests. Then another project to perform the contract tests. And a third project to build and deploy the Docker images.
All Gradle?
Everything is Gradle, yeah. Yeah. Question was if we used the root project to declare or define dependency versions, and if we use a parent pom in Gradle. Yeah. Yes, we did, or we do. I showed it before where we enforce the versions and declare some dependencies. This is done in the root build Gradle, and the sub-projects only declare their dependencies. Yeah. Yeah. Question is if we publish our sources to GitHub. Answer is no. So one question asked in our team or other teams, why do we use Gradle? What's so good about it, and why do we have to change it? Because there's some investment, especially for big projects. Well, on that FedEx day, lines of code is not the best metric for quality, but you see 18,000 lines in pom.xml and 3,000 lines in Gradle files. I guess the smaller files are better manageable. Pom files are XML, and well, it's too noisy. Just like the example with Docker, talking with a remote API, it's simple because you just use Groovy. So it really is fun, and in Maven you have to find a good plugin, Gmaven or something. It's just no fun. Well, what also helped was quite quick feedback from Gradle developers or from Gradle support, especially with the init plugin. There was an issue which was fixed during that FedEx day, or where we got a hint to use a release candidate. That was great for us. And also in the support forums, there's quick feedback. Mostly after a day you have an answer or a solution. For Maven, I don't have that experience. Well, and as mentioned, it's groovy. It's just great. So, I'm finished. You still have questions?
Can you at least share the slides? I can see the snippet of the code.
The slides are available online. You should find it on the Gradle Summit pages. You will find it. Yeah.
Similar to my original question about the IDE, I assume you said you're using IntelliJ. Is that true throughout your organization? Do you have any Eclipse users?
Yeah. Question is if we are using IntelliJ through our organization. Yes, I guess, completely use IntelliJ. Yeah. The other question was for the camera. If the slides are available online, and yes, they are. Just search after my name and you will find it. Yeah. Yeah. Question is why we switched to Gradle even if the build time is quite the same as Maven. The build time hasn't become worse, so it's we don't lose anything. But there's potential in Gradle, and they are still improving in performance. So I have to check again if the times are still the same, or if it has already improved. But Maven doesn't seem to become better. Gradle has that as focus to become better. Other questions? Okay, thank you.